Hello. So, we will continue our discussion on cloud computing, and today we will talk about a typical use case of spatial cloud, or more specifically geospatial cloud, right. So, what we mean by this geospatial data and information and type of things. So, what we see these days, that the spatial information about earth surface, and both with coordinated system, right, with location based information are becoming extremely popular. We all of us are more or less used to or using day in day out these location based services or navigation services for finding trajectories from one location to other and type of things, right. So, all these are possible because there are spatial data which are being maintained by various organizations, right. As data is becoming more heavy with, and multiple organizations are storing this data. So, there is a need that how to integrate this data for decision making purpose, right. One, navigation may be one of the things. There are several other decision making things, especially different development program of government and means government agencies or state agencies and type of things, which require some sort of a ground level information to be integrated, right. So, one way of looking at it, that I store the data in a central place and then query on the look at the things, right. But if there are multiple stakeholders of the data or multiple providers of this data, then this making it as a central repository sometimes become a challenge, right. First of all, the data itself is cost intensive. There are expertise and there are manpower, there are fund involved in in collection and maintenance of the data. So, once you put the data in some other place, then the whole thing goes for a different type of management, right. Secondly, the volume of data is enormous. So, this sort of transferring of the data over things may be extremely difficult, right. So, what one of the solution what this spatial science or spatial management and things are looking at, whether we can migrate to a cloud, right. It's some sort of a cloud sort of infrastructure which can be provided on this platform, right. So, there is a lot of work going on across the globe, and we would like to see that what is the feasibility, what sort of things are they in here at IIT Kharagpur. Also, we have a small group working on those this sort of activity. So, we will try to see that what is the feasibility of this sort of domain, spatial domain going to the cloud, right. So, if you look at, so this is all we are discussing for long, like what cloud gives a on demand service, ubiquitous access, resource pooling, location independence, rapid elasticity, measured services, right. And so, this is one part of the cloud side. If you look at the geographic information side or the information spatial information or geospatial information side. So, information explicitly linked to the location on earth surface. We are primarily looking at the spatial data which is looking specifically on the earth surface, right. So, it is a coordinate driven thing. So, every data has a location. Incidentally, if you see or there was a report that more than 90% of our data are somewhere or other related to some location, right. Suppose if I see our student data here. So, along with lot of other things, it says that which hall he or she is staying, which department he or she is studying, right, where is or his or her hometown. So, all those things has a location on the earth surface. So, somewhere or other with this spatial information is inherent or it is there in all our day to day life. Not only that, in most of our databases also, right. We may not be using it, but it is there. If there is a pin code, it says that which region it is referring to, right. So, it is explicitly earth surface. Geographic information can be static or dynamic, like static which does not change with time or changes over long period of time, like it may not be like a boundary of a state or a boundary of a district or sometimes a park, lake, etc., they are not changing day in day out. There are can be dynamic, like some of the say traffic movement or population of a particular city which varies over time, right. There are a lot of influx during daytime, people are going out during night time and type of things. If I look at this particular building where we are sitting here at now, and so it has if you look at the building wise, it is static, right, or we can say pseudo static, it is not changing day in day out. But if you look at that the footfall on the building, that is changing, right, or even electricity need of the things may be changing. So, some of the data can be static, some of the things can be dynamic, and there is a typical thing, this geographic data varies over in scale, right. So, information can range from meters to globe, right. Some of the data, if I want to point, it needs a up to a meter scale, right, and find out that what is the location of a lamp post, right, or but it is can be higher, the basically the map of a country or map of a district or map of a state may be much larger scale. And scale versus detail and ecological fallacies, and those things are there. So, with the scale things goes on changing, right, like if I look at a building from a higher from the sky, it is a point, but if I close down, it becomes a polygon, and the with the scale the overall nature may change. So, these are some of the characteristics of the data, right. And if you look at that common geographic data which we are accustomed with, there can be some legal data, that is location, this boundaries, etc., political maps, cultural, climatic, some economic, etc. So, there can be n number of such structure, and there can be different agencies who are collecting the data or who are maintaining the data. There can be some sort of social survey, there are natural survey like we have Survey of India maps, etc. There can be some remotely sensor based things or sensor data, like it can I can have remotely sensed data like air photos, photograph taken from the air or satellite images, even reporting by weather stations, collected by GPS and map marking associated with some attribute interest. There can be pollution sensors across the things which gives data with locations where things are there. There can be air quality control, pollution sensor, temperature sensor, another type of atmospheric sensors which gives data. So, these are different sources of data. Incidentally, these data are maintained by different organization by their proprietary nature, and when I want to query on more than one such data, that I may need to share or interoperate between the data, right, where this we need to see that where this cloud will be make some sense where using it. So, if we look at some of the formal definitions, like for capturing, it is a capturing, storing, querying, analyzing and displaying geospatial data. Geographic information system are tools or platform which allows you to spatial data information related explicitly or implicitly for the earth surface. So, we are not going into deep with the things, just to show that what sort of data, just to have a idea of the thing. And it can have hardware, require hardware, software, data management is a major part, spatial data which has a different type of characteristics, both volume wise, meaning wise and type of things, and you require a special category of people who can operate on this data, right. So, that is what we say, people who can work on those type of things. So, these are the different component, and what are the major challenges which are faced by this sort of huge spatial data? It is data intensive, it is computation intensive. If I want to find a shortest path from A to B, where the number of roads etc. are like if I look at the represent them as a road network as a graph. So, huge volume of the things of this graph, then it is extremely computational intensive. Not only that, if I want to find out a some sort of a overlaying type of things, then also it is computational intensive. So, variable loads on the GIS server demands dynamic scaling in and scaling out of the resources. And another interesting thing, it is not like that always you are doing work. So, data is there, whenever the query comes you are doing, and that it may also varies depending on the things. So, we may require scaling in and scaling out of resources, right. So, that will be advantageous, that when I have huge computation, I scale, bring in resources. When I do not require, I release those resources type of things. So, there is a chance of having this sort of utility based computing or cloud sort of computing here, and uses number of time uses network intensive web services. As we have discussed, web services are services which are based on this service oriented architecture, and instead of data driven we have a service driven. So, we are talking about spatial web services which takes care of spatial data type of things. So, it is extremely network intensive because the data at varying place maintained by different organization, and you need network intensive thing. So, if we look at a typical patch of land. So, if you see the spatial data, there can be hydrological data, there can be elevation data, soil data, infrastructure, same place, and we require a referencing system, right. The means best or the well known referencing system what we understand from our school days is the lat-long. It can be other referencing system which basically try to pin the data to a particular location. And if this is not only true for spatial data, it is true for any sort of data repository, like we have operational data, then summarization, making schema, then metadata information of the schema which contains not only this schema information, lot of other things, and there are business rules which the finally the end user wants, right. That I want to know from location Kharagpur, IIT Kharagpur to going to say IIT Chennai, what should be the route, or IIT Kharagpur to some place in Kolkata. So, I am not bothered about that how where data is stored, how they are maintained. I am more bothered about that what should be my path and what are the POIs or the point of interest across the path, and how I should move, and what may be the expected time to reach that things, what are the congestion level, etc. So, I am more interested in the service rather than the actual data itself, right. So, these are required. So, that is my business rule, that I want to find a shortest path. I may want to find a particular corridor of the things, like if I make a say if government makes a canal. So, what should be its catchment area, how much it will serve. So, it says that if there is a canal is so much flowing water is there, then I want to see I means if the rule is that it says that both side 2 kilometer buffer will be the catchment area where the water can be served. So, out of this 2 kilometer, how many population has been served, how much land, agricultural land has been served can be the way of can be my calculation. So, that is my business rule. So, the end user is more at the top of the things, and this is true for all sort of data, and we have some of the verticals like data security which has end to end. There are quality of service, how reliable, there can be management services and different other verticals which goes from the different aspects. And what we try to see in case of especially in case of this sort of spatial data or geospatial data, we want to have some sort of a homogeneous way of looking at it, like that different organization keeping that data. When I query, I require them in the same type of format, same type of means both syntactic and semantic wise some sort of a homogeneity. Otherwise, I cannot query on the data, right. So, some referencing system is different, then I cannot query on the data. If the scales are different, then also I cannot query on the data, right. So, that we need to resolve issues like data description, that where homogeneous I should understand, standard encoding of the data, standard mechanism of the data sharing. So, all this what it says that some sort of a computing centralized computing facility which are like cloud type of things which can be helpful for the things, right. So, though I can have this separate type of data, like it may be some data of the street, building, vegetation, but some sort of a homogeneous integrated data I am looking for, because I need to query on this data. And we have seen that the trend is now more of a starting from the project mode, now of a more a societal mode. That means, data is available to everybody based on, because it end of the day it is taxpayers money. So, based on the considering policies, securities, etc., but it should be available somewhere ubiquitously. So, that may be a cloud may be a solution. Another concept came up, or rather very popular in advanced country, also becoming popular or becoming a need in our country also. It is a making a spatial data infrastructure. So, looking the data as a infrastructure. So, whenever I want to query on the data, I hook into this infrastructure. So, right. So, it is a infrastructure. So, some sort of analogous I can we can look at that our telecom infrastructure, right. You have there are different stakeholders, and they have different type of say policies or plans, etc., but I have a overall communication infrastructure. Somewhere or other, if I hook into the things, like if I have a SIM card with particular plan, then I can access voice, data and multimedia type of things, right, based on again I pay as I go. So, but as such the telecommunication is the infrastructure, right. So, whether I can have a spatial data and as infrastructure, if it is there, then I can do a lot of things, like I can do say planning for like what government does for say development planning thing for developing a particular area, setting up a school, to some disasters management also, right. Otherwise, you need to always collect data, put somewhere and do this. So, this sort of infrastructure is the need, not only it is becoming true for our country also slowly. So, in other sense, what we need, there can be different way of accessing the data, there can be different instances of repositories. So, what we harvest here is more of a web services or spatial web services, which can take request from here and talk to the backend databases and serve the data, right. So, what we see that huge volume of data and metadata, need of services and service orchestration, because if my business rule may not be a just find a shortest path, I can have a things which has a series of services or the processing service to be initiated, evolving standard and policies, need for this basically lead to a need for a spatial cloud, right, or geospatial cloud. So, there are, as already we have discussed these points, but just to look at. So, private public organization want to share the spatial data. So, different requirements for spatial data space, network bandwidth, etc., based on the data volume, get benefits from other things, sharing the things, less infrastructure and spatial service expertise needed, right, that is another important thing, right. So, if I want to store, if I am a organization of collecting data and storing, so I require a infrastructure to store data. The data are voluminous, data are requires a different type of bandwidth, etc., and I need a processing thing. And not only that, for that I require separate expertise or manpower to do that. So, if I have a and as we understand that every infrastructure goes off, or in the sense has need to be renewed every 3 to 5 years. So, it is sustainability of these things becomes extremely difficult. So, instead if I hire a infrastructure for my purpose, that can be a more beneficial thing, right. So, sometimes the organization lacks, who are more specialized in spatial data, lacks in maintaining the infrastructure, and GIS DSNs are used ubiquitously in various government, semi-government and private things. And if we look at the spatial cloud or geospatial cloud, so it will support shared resource pooling, which is useful for participating organization and common shared goal, as we are discussing a couple of slides back, that it may be bumpy the requirement, that means I need to scale up, scale down on my resources. So, it is a shared resource pooling can be there, and choice of various deployment service business model to best suit a organization requirement. Managed service prevent data and work loss from the frequent outage, etc. Like, so if it is having a more managed service and which may minimize my financial constraint, etc. Provide controls in sharing data with high security provision of the cloud, as cloud also looks at the security features and looking aggressively on the security features. So, and security always come with a lot of cost. So, all we can leverage on the things, and it can be much what we say economical to use those type of things, and organization can acquire web service space as per their need. So, if I need only this sort of spatial services, I only harvest those services, right. Or if I need this type of data, I only look for this data. So, it is customized based on the need from the infrastructure, right. This is the NIST definition, I just repeated. So, already we know. And cloud advantages also is known to us, that scalability on demand, minimize IT resources, improving business processes, and all these advantages minimize startup cost, consumption based building or pay as you go billing, pay as you go model, economy of scale, green computing. These are all a need for this spatial data infrastructure or spatial data management and type of things, so geospatial data infrastructure. So, that means it is somewhere it is suited for this type of things, right. And this also we have seen that there are who are the cloud actors, like one we have cloud service CSP or broker, customer is the other end, negotiator is can be optional, that negotiate between cloud, and SLA manager or security auditor. So, if we look considering all those things, and if we look at a typical cloud architecture for geospatial data, this architecture may be true for any type of other services, but if we look at the geospatial data where the geospatial or spatial services are put into place. So, this overall things come into place. So, there is a once a customer or a user or a service consumer comes into play. So, there is a negotiator, which there can be number of brokers where which basically broker acting as agent for different data or different sets of data. There can be the same data may be handled in two repositories, it may so happen, and we have different data centers which gives VMs, and there are different organizations which launch their data and services on these VMs, and these are being negotiated and connected with the end user. They are other than this, we require a SLA manager to see that this SLAs or service level agreements are not violated or things, and there can be a auditor or auditor to see that whether this sort of policies in terms of SLAs, there can be security auditors, security policies etc., are being maintained in this type of situation. So, I require a brokering service or who broke for the things. There are different data centers which host this spatial data of various organizations, and there can be SLA, there will be a SLA manager and auditor which takes care of the overall management things. There can be other component of the thing, other different components, there can be separate auditing services etc., but this is the overall broad infrastructure. So, if I look at some sort of enterprise GIS or what we say some sort of a realization of this SDI which gives spatial services, what we mean by this enterprise GIS is that it itself does not have any data per se, but it basically allows the consumer or the customer to connect with different service provider. So, it's a some sort of a cloud or some sort of a middle tier which connects those things, right. So, resource service, resource allocation manipulation, data services, interface services all can be provided. And we can see that a typical structure, we have different instances of this. There can be, so this is my backbone hardware. Over that we have this hypervisor which emulate different virtual machines. There will be gateways. Over that I can have different type of instances of this spatial cloud, right, or instances of this spatial web services which are there. So, I can say that if it is say that spatial web services for a particular organization, maybe particular state, maybe particular district can be instantiated on the things, right, and then I work on the thing. Like if we try to look at some sort of analogy, may not be very good analogy. So, if I say that when I am using some word processing service on the cloud, say Google Docs. So, what we are doing? We are basically instantiating my domain on that particular Google Doc, right. Somebody else is again instantiating things, but at the back end it is the same, it is the basically the Google infrastructure we are using, where the hypervisor, and it is a basically software as a service. So, we are at a much higher level, but it is instantiating my thing. So, here whether I can have special service instantiated for my particular work. So, if we look at the geospatial cloud model, so web services here also key technology to provide spatial services, need to integrate data and heterogeneous backend data services. Service can be data service can be inside or outside the cloud, they can be that some of the services can be outside, can be run through PaaS service model. Using PaaS makes load balancing etc., we can make scaling transparent. So, one way of looking at it, that a typical scenario where different organizations are there, and I have a one coordinating cloud which has the central repository which takes care that where the organization, how they are working and type of things, where the data is there. So, that we have already discussed, need to integrate data in a unified format, or homogeneity it need to be instead, or interoperability is there, performance metric, computation power, network things etc., need to be judged, and there can be various data sources. We just show some snapshot that we made a experimental geospatial cloud, I should say, in our at IIT KGP on our own experimental cloud, that Meghomala, where we have seen that which runs on OpenStack open source cloud platform, and it is a in-house cloud used, it is a private cloud to IIT Kharagpur, and over that we have did some experiment. So, as such we are not showing the some performance data, but showing that what sort of things may be there. So, this is a particular area, this is a area of a Bankura district, which is a district in West Bengal. So, if I have a highway which is supplied by say highway National Highway Authority, and on the other hand if I have a local road network which is a more handled by the state or the district authority, then how to query something which involves this. Now, if you though the image may not be clear, these are running in two separate VM. It is something 1.74 here 1.75, on the fly I want to have a processing service which integrate, right. So, taking these two, I basically have a merge node network, right, or in other sense I have a two services of the road I am pulling and having a merge road, or having the national highway over that, and there we can basically now query for a shortest path on these things, right, which takes care both this national highway and the state highway. Like if it is my two location and then I want to find out the shortest path, it does on the on this combined things. So, though the application may be trivial, if not trivial, it may be a well known application, but see two separate repositories we can pull on a service mode, and which are running on two different VMs, and pull on a service mode, and basically my business rule is finding the shortest path, right. I am not neither interested in the whole data of West Bengal or whole data of India of road data, I am interested in that shortest path and which are the locations. So, this is one sort of thing. So, other thing I can have again two sort of data where I have one a canal type of things on a same Bankura districts, and a river data which can be in a different thing. Now, I want to have a merge water network which integrate this canal along with the river. Again these two are in the separate VMs or separate cloud instances. I have a merge data and I want to buffer on this merge data, right. So, try to see that during heavy rain or flooding, what are the things which if the business rule is that within 500 meter it is vulnerable, then what is the vulnerable area of this particular buffered zone. So, again I have two separate data instances which are integrated on the fly and gives this query, right. So, here we have experimented on a experimental geospatial cloud we have installed over our Meghomala thing. So, there are several challenges here other than which are typically for the spatial data which are not there in other type of what we say non-spatial data type of things. So, implementation of spatial database is a one of the challenge. It requires a lot of not only space, need to understand the data semantics also, scaling of the spatial databases, right, need for multi-tenant thing, policy management among these different tenants, geographically situated backups if you want to keep, data security. Some of the challenges are also there for other type of things, some are typically for this type of spatial. And also we have a major challenge of interoperability, right, data level interoperability, like one data should match with other while we are doing say buffering type of things and things. It can be a service level interoperability, like two services can talk to each other. Security level interoperability, like when I have different policies on different data sets, then what should be the security level interoperability. So, major security concern is the multi-tenancy is already for other things and lack of complete control of data application services. There are several other concerns which assets to be deployed on cloud, what is the value of these assets, what are the different ways this asset can be compromised, etc. So, there are different type of other concerns which we need to look at. In if we look at the overall spectrum, so this spatial or geospatial domain finds a immediate applicability or a huge applicability on this sort of a cloud thing. So, one of the good use cases which not only in our country, in different organizations in different countries, how to make this heterogeneous data talk to each other for different type of citizen centric development planning and disasters management is becoming a popular aspects of spatial cloud, and this is a good use case. Thank you.